Good afternoon, everyone. It's great being here. I don't know. I was just thinking about it sitting there. This is my 30th year that I've been in some way, shape, or form educating architects, and I thought about how I got into this as a building scientist, and I think it's because, as I always tell people, at the end of the day, these are the people that do all of the integration, and so if you can't get them to think through it properly, you don't have much of a chance of getting your buildings right. So it's important that we think about all these things. And today I wanted to talk about sustainable roofing strategies. Oh, okay, that's better. I wanted to start with the idea of differential durability because it's something that I sort of came upon as a researcher, I don't know, maybe 15 years ago. And I thought about it looking at the world around me and how certain things aged quickly and certain things didn't age, or looked good and looked bad, and so on, and that the chain was only as strong as the weakest link. And so this whole idea, and of course with building skins, it's pretty obvious as to how this plays out, and we can see examples of it every day. And it started to sort of beg larger questions. And when we look at roofs, and believe me, there's all kinds of roofs in this world, roofs are probably where the questions begin first, just because of how they look and how they're occupied and so on. But sort of the thing that sort of came up was, well, should walls, windows, and roofs all have the same service life, or should they be different? That was one big question, because people sort of always imagine buildings, I think, when people are being educated about architecture as well, they're always looking at monumental architecture that has lasted. I always tell people the thing about looking at old buildings, the really old ones that are still here, is that they're all the winners. All the ones that aren't winners got demolished or whatever, and they're not there anymore. So we use them and we think, oh, well, they seem to just last forever, so that means that all of the durabilities are the same for every component in that building. But the question is, well, we don't build buildings like that anymore. They're a lot more technologically advanced, and they have to perform a whole bunch of different functions. So should they all be the same, or could they be different? That was always sort of a big question. Architects, designers have to establish building DNA. When you set up DNA, it sets up everything in the world of biology. And it determines all of your characteristics, traits, and eventually, to a larger degree, when you're going to expire. So this image is interesting because this is what people do in Eastern European apartment block buildings. They do whatever they want with their apartments because they can't wait for people to come and do maintenance, and they didn't like it. And so you'll see that each one of these is absolutely different, and some have air conditioning and some don't. This is what happens when you don't have a plan for how the building is going to evolve. So this is the stuff that's been going on forever. You can go all the way from monumental, which means I'm building a building that's going to be here 500 years from now, right to throwaway. I'm building a building that's going to be a sales trailer, and then after the condos are sold, then they take it down. And then you look at all the stuff that makes up DNA, like form and fabric and finish and facilities and furnishings. And in each case, they have a sort of an implication of part of the design of the building. And so that sort of gets you to the point where you have to ask big questions, like, is the building design static, fixed in time and purpose, or is it flexible, universal, and capable of adaptation via migratory paths to sustainability? And today we're starting to see a lot of idiosyncratic buildings that will only do the one thing that they're meant to do. But really what we're going to need as a society going forward are buildings that will undergo many, many different uses. So this building here is probably always going to have this use, and for a good reason. It's a great cultural resource, it's a beautiful building, and that's the way it's going to be. But what we discovered with many of our industrial buildings, they've had many lives. They had industry in them, and then things happened, like artists moved in, and then people have architects' offices in them today, and the old Victorian buildings, post and beam, with the regular floor plate, they last. Anyway, so you have to ask the question, which way are you going to go? Not every building can be monumental, not everything can be idiosyncratic in a society like ours. And this is your struggle. everyone knows this. I have to integrate things. This is what architects, this is what designers do, working with engineers and other types of specialists to make sure that these things somehow connect together according to that DNA, whether that building is a hospital or an office or a school or an apartment building. And it's all got to come together, and it has to actually perform according to some owner's performance requirements that have been set out, and in many cases, minimum requirements and codes and standards. So it's a challenge. It's a challenge, but we're evolving, and this is what's important in addressing this challenge. That's what I wanted to talk about today. We should recognize that the building service life cycle is something that we have to decide fairly early on, and then we have to look at what that implies in buildings in general. So, structures, we know if they're done according to our latest sets of standards for steel or concrete, and soon we're going to be building structures in wood, and we have evidence of wood structures in Nordic countries in Europe that are wood and are there 700 years later still. So, but for sure we know we've got 200 to 500 years on a structure. Certainly if it's reinforced concrete or structural steel, it'll easily last that long. The enclosure is about 15 to 100 years depending on which part of the enclosure you're talking about and what quality is selected, at which point you got to do something about it. Services and equipment, excuse me, about 10 to 30 years, depending again what you got. And interiors are about 5 to 25 years. People do a lot of churn rates and changes. So think of how each of these cycles fits within the bigger cycle of the sort of 200 to 500 year life of a building that we build today, if you assume that the structure is going to last that long. Now the building may get demolished long before that just because it's functionally obsolete. In other words, you don't need it for anything anymore. Another way to look at this is, when you're trying to figure all these things out, is what's the cost of failure or retrofit? So this is what I always like to look at. As an engineer, risk and consequences are huge. The old rolling of the dice. I always like that line out of Dirty Harry. Well, punk, are you feeling lucky? Is that the roofing system you want to pick? Foundation basement type failures. When you have this happen, the building is basically done. Well, you can fix it. I mean, they worked on the Leaning Tower of Pisa. You know that they actually could have straightened it all out, and someone said you can't because it's the Leaning Tower of Pisa, you idiot. It's got to have a lean to it, but it was starting to lean too much. So they said, okay, so there's an example. But really, this is so costly. It's unreal. Your building's finished when your foundation is screwed. The money is huge. Structure, if you have structural issues and you have to go and address them in a building, again, lots of money. Walls and windows, yeah, well, you know, there's going to be a bunch of people in glass condo towers. They're going to one day wake up to realize that their little R2 enclosure that's all window wall is not that good anymore. It's going to cost a lot of money to fix it up. So not as much as fixing a structure or the foundation and basement. And then you get to roofs, and for some reason it's just not as much money to do roofs, and people always say, well, I wonder why. It just happens to be the nature of the beast. You know, we're not going to get into philosophical discussions about that, but it's just a fact that roofs, the cost of their failure and their retrofit is generally something that is more manageable. So that maybe gives you some idea of how you prioritize your design thinking. Now, we did something remarkable a long time ago. We did the separation of skin from structure. So, you know, these monolithic type of, masonry buildings and so on. These types of structures that gave us sort of the history of architecture, and you look at the Greek runes and all that sort of stuff, you go, yeah, that's the way we used to do it. But really, the separation of skin from structure is a much more sophisticated concept, and a bunch of people actually beat us to it, but we never recognized that, and that is that we started to do frames, and we started to have structure and control layers and claddings, and we got liberated from monolithic monumentalism. And finally, we could give our buildings a wardrobe. Now imagine that, because this is one of the ways I explain things to students. I said, imagine a building that can actually change in a way, because you've planned for it. Imagine what it would be like if you didn't plan for it. So I tell them, I say, you get to pick a wardrobe. The wardrobe that you pick, you will wear for 12 months of the year, and for every year of your life. That's what happens when you put a skin on a building. Normally, but if you think about it, you go, well, that's not really bright. I mean, do you want to wear a parka in July? Do you want to wear Bermuda shorts in January? Why do we have buildings that are so static? And so we can start to think about that, and we can also start to think about the life cycle. So we look at the human skin, it does it all, and really buildings are prosthetic devices for humans because we are so frail. And this thing is huge for us, and it's got all kinds of sophisticated things going on it. I couldn't believe the 50 million bacteria in 1 square inch, but in fact, yes, I triple checked it, and that's how many we have. If you ever wondered how many bacteria are crawling over your body, think about that the next time you're making love with somebody. Now you know why people pick architecture instead of biology. But the skin regenerates itself approximately every 27 days. That's good. The bed mites love us for that. They're eating our skin all the time. And this is something that's biological, but we have to now think, well, how do we do that in the world of static buildings? And can we even imagine that? So before we even get to that kind of thinking, there's a few things we have to realize. See this picture here? Well, imagine how many roof penetrations there are. And the question that you have to ask yourself is this: good roofing versus dumb design. No matter what roof you put on this building, what are the odds of it leaking when you have that many penetrations? And when the time comes to do something with that roof, what will it cost? Just because someone said, I want to put all my equipment on the roof, and I don't want to put a roof over top of my equipment. Like, really sort of a dumb move. And you're setting yourself up, and at that point it doesn't matter. I don't care. You could get titanium and put it on the roof. You're going to have major performance problems. So the dumb design thing you got to get rid of right off the bat. And then you got to look at what matters. I love this picture because there's these buildings that have been around literally for hundreds and hundreds of years. But then there's the air conditioning units, television, satellite dishes. What does that sort of tell you? Well, these building structures obviously define the architecture. The service technologies come and go, and they do. In the life cycle of a building, they just come and go. They're like hats. They come in and out of fashion. Form and fabric always remain, but the fabric needs to be renewed. And we just haven't been around long enough as a country. This is one of the things that's interesting about Canada. It really sort of got mostly built after the Second World War. We're not used to the fact that we have to actually renew things. You go to older cultures and they go, yeah, well, you don't have to renew them. You can just let them deteriorate. Go to Cuba, go look at some deteriorating buildings. So this is what you have to do now. You have to think about this. You got to arrange the DNA to optimize life cycle performance, and the designer, along with his crew, figures all of that out, like the human skin and car tires for that matter. Roofs are sacrificial layers that need to be designed for renewal, the same as walls and windows. We just haven't had our buildings long enough to realize that's actually what we have to design for. We've been designing for monumentality. There is no such thing. Everybody that's in this room today, one day will be dead. That's just the way it goes. Nothing lasts forever, so you have to think about the replacement. That's why you have children, hopefully. 12-year-old building, gone, functionally obsolete, didn't make sense anymore economically, let the thing go. So, you know, think about that. We're stuck with our buildings. We certainly are. And you look at Toronto, that's for sure. And we just can't afford to replace them all. So we have to now start to think, right from the day we design, we have to think about designing for maintenance, designing for replacement. We cannot think about something as, oh, I'm going to spend the money, it's going to get done, and that's it. You know, there's no such thing as maintenance free. And that's especially true when it comes to marriages, I discovered. So you got to plan. You got to plan for these things. And so the life cycle of regeneration, if you look at it then, is that the future generations that are going to inherit all of this stuff that you're looking at here and all the built environment, they can't be locked into the design thinking that we've traditionally had. It's just not fair to them. We need to have regenerative architecture and perpetual skins. We have to think that way now. It's a new way of thinking in a low-carbon economy. We have to plan for deterioration and renewal. Who wants to do that? How many people want to do? They always sit there and go, that's horrible. Like, I always thought that the way that I designed the building and the way that that picture appeared in Canadian Architect magazine was the way it would look forever. And you go, no, just go back and look at them. That's one of the exercises I always give to my students. Pick any building you want, it's got to be 10 years old, at least. Go look at it and compare it to what the photos look like. And they're like, it's terrible, it's got stains. It's like, well, I know, it looked really good the day they took the pictures though. everything deteriorates. Everything needs to be renewed. You have to have strategies for that. So you should be privileging high-risk failure and retrofit components. I mean, you should look and say, well, if it's really super expensive to fix the foundation, if it happens to settle the wrong way, then I got to really make sure I get that right, the structure I have to get right, and so on. And then you finally, you get to the roof. And at that point, you have to never forget that we are too poor to be cheap. We as a society are no longer so affluent, and you can see that by the economy we're in now. And with most young people going to university not being able to get decent jobs when they graduate, we don't have the wealth to just replace things perpetually in a haphazard fashion and just tear stuff down and put new stuff up. We've got to spend enough money that it's going to last. So here's what it all comes down to at the end of the day. And this is what we've done in the past. So this is the one type of formula you can go with. Build cheap, maintain expensive. This strategy is exactly where we are today in our culture. We build cheap, and then it costs a fortune to maintain, and then they don't maintain. At my university, which has a lot of smart people, a lot of people that are a hell of a lot smarter than me, we're at $350 million in deferred maintenance. Why? Because we don't have $350 million. How did we get to that? Somebody wasn't really paying attention. Well, why? Well, they don't do asset management. Well, why? Well, because they never really thought of it that way. We're just starting to come up to that. We've bumped against the outer envelope. So with this new awareness, you say, that's okay. It happens. Humans make mistakes. But do you learn from them? That's what makes the difference between whether you survive or not. So there's that option, or there's design for renewal and resilience. If you're going to think that way, it's a different ballgame. You start to plan and you say, just like people when they were designing car tires, they said, you know, wouldn't it be nice if all you had to do was undo 5 bolts, pop that rubber off the rim, put on a new tire, put back on the 5 bolts, and you're good to go again. And somebody goes, that's brilliant. I thought we had to rip the whole car apart. Yeah, I did, and most of it would end up in the landfill, and that would be terrible. You'd sit there, I would never tolerate that. Most of my car gets stripped away just because I want to change the tires. Well, they wear out. Okay, if you know they wear out, you design for it. Well, we figured that out with cars. We're just coming up to an era where we're starting to figure that out with buildings. If you have a real problem with trying to figure out which way you want to go, there are many different solutions. You're hearing about them today. People say, is there any right answer? Not really, because it's so contextually driven. Sometimes people say, well, you know, sometimes certain buildings demand a metal roof. Certain buildings actually have to have a green roof because of a bylaw and so on. So different strategies come into play. And you have to pick the right ones. But you got to think about it when you're setting up the DNA of your building. It's not something, you know, if you're God and you're making giraffes, you got to make sure you make that neck long enough that they can reach the branches that they're going to feed from, because otherwise they starve and then they go extinct and there's no giraffes. That's what engineering DNA is, except it happened the hard way through survival of the fittest. Well, you don't want your projects to be survival of the fittest. You want them to survive and be resilient. So when you have these types of questions, there's a lot of people in this room that can help you. I hope you get a chance to talk to them. They're very knowledgeable. If you're really stuck and you're feeling philosophical, you can call me. I don't charge a lot of money, but I really like single malt scotch. Thank you very much.